Hello everybody, it's Miss Wiley, and today I am coming at you with some more factoring. Today we're going to talk about some more patterns in factoring. And what's lovely about these problems is that you can use the same methods that we have been using to factor, whether it be guess and check or grouping. In this video, I will be using a guess and check method based off of the patterns that I notice in these special products. Before we begin, we're going to do a little warm-up, and to give you a little reminder for the warm-up, when you look to the second and third example here, just a reminder that when you have a binomial to the second power, the way that you have to think about that is you have to think about it as that binomial times itself. You cannot distribute an exponent into a binomial, so this is the way that you want to think about it when you're doing these two problems. So please pause the video and multiply these three examples out to get their product. Okay, you should have tried each one of these. If you didn't, then follow along. So for the first problem here, multiplying the first terms together, I get a squared, and then multiplying these outside terms together, I get negative AB. Multiplying the inside terms together, I get positive AB, and multiplying the last terms together, I get minus B squared. Combining like terms, these would be my middle two terms, I get A squared. I get A squared minus B squared as my final answer. Looking to example 2, remember I had explained to you before you did the problem that you need to write this out. Remember, when in doubt, write it out. So if you're not sure if you can distribute that, then don't. So going ahead and multiplying here, I get A squared plus AB plus BA, which I like to write my variables in alphabetical order. So B times A is the same as A times B, and B times B is B squared. Combining my like terms, I get A squared plus 2AB plus B squared. If you have a 1AB and a 1AB, you get 2AB. So then this is your polynomial that you get. Same goes for number 3. Number 3 is a little different than the second example because it has a minus sign. So let's see what we get here. A times A is A squared. A times negative B, negative AB. Negative B times A, also it's negative BA, but you can switch that around to negative AB. It's the same thing. Negative B times negative B is positive B squared. Pay attention to your signs. Combining like terms, bring down the A squared. Negative 1AB minus 1AB is negative 2AB. Bring down the B squared, nothing to combine there. And then this is what you get as your answer. Okay? So you can see with each of these problems, I was able to use methods that we have used before. Let's talk about what each of these products are. Each of these products represent a special type of product. Okay, so the first type of product that we are going to talk about here is the A squared minus the B squared. This, if you remember from our previous notes that I had given you, this is what we call a difference of two squares. Okay, so the way that we can recognize a difference of two squares in its factored form is that it's the same terms but opposite signs. You are now going to be working backwards with the problem where you're going to take this and we're going to work our way backwards. Okay, so going back to this here, this is what we call a difference of two squares. Sometimes you just call it a difference of squares, so I'm just going to write difference of squares. a difference of squares can be recognized by a couple things. Here's how you can recognize a difference of squares. First of all, it will be two terms. So it'll be a binomial. There will be a minus in between. And the reason why they call it squares is because both of these terms will be what we call perfect squares. Okay, so both terms are perfect squares. Reminding us of what perfect square numbers are. Those would be numbers like 1, 4, 9, 16, 25, 36, 49, and so on. Okay, it's probably good to be able to recognize your perfect squares up to 12 squared. But again, at home, if you need to get out a calculator, go for it. The way that you can recognize that a variable is a perfect square is x times x is x squared. X squared times x squared is x to the fourth. X to the third times x to the third is x to the sixth, and so on. Basically, if the variable has an even exponent, then it is a perfect square. So that's how you can recognize a difference of two squares. So let's go over an example of how we would factor that. So here's an example. So let's look at x squared minus 9. If I factor x squared minus 9, one thing to know about a difference of two squares is that it will factor into two binomials. And the reason for that is because it's still in the form of ax squared plus bx plus c. It just happens to be that your b term here is 0. 0x, which is 0. Let me reframe that. So it's the same idea, except there's no b term because the b is 0. Okay, so it is going to factor into two binomials. So I'm going to draw two binomials and start filling in the blanks. Okay, how do we get the first term? Well, we get it by the first terms. How do we get the last term? We get it from the last term. So it's going to be 3 and 3, and plus and minus. The reason why it's going to be a plus and a minus is so that you can get negative 9. Okay, now how did I know to use 3 and 3 and not 9 times 1? It's because a difference of two squares will follow the pattern of this up here, where both the terms will be the same, but the signs will be opposite. Okay, I had mentioned that before. It's like, kind of think of it as same terms, opposite signs, sort of shorthanding that. It's not a very technical way of saying it, but that's essentially what you have going on here in the factored form. So I know when I'm factoring a difference of two squares that my terms are going to look the same, except for the sign in between is going to be opposite. You can check your answer, just like we always do. You can check to see that that middle term gives you 0. When you check your answer, look what's going to happen. X times negative 3 is negative 3x. 3x and negative 3x give me 0. That's why the b term is not there anymore. It cancels out. Those like terms cancel out just like we saw in that first warm-up. So then this is your final answer. Let's look at another example. In example 2, we have 4x squared minus 1. Everything in this problem is a perfect square. 4 is a perfect square, x squared is a perfect square due to the even exponent, and 1 is also a perfect square. So I know that this is going to factor into two binomials because it is literally the difference of two perfect squares. So I'm going to draw my two binomials. Remember that the two binomials will look the same, except one will have a plus sign, one will have a minus sign. The way we split up 4x squared into two terms multiplied to themselves would be 2x and 2x. 2x times 2x is 4x squared. The way that we get 1 is 1 times 1. If you want to check your middle term, you can see here's your negative 2x, here's your positive 2x, which will give you 0 in the middle. And then this is your answer. Last example of difference of two squares for you to try. X squared minus 16y squared. Pause this video and give this one a try. You should have recognized this as a difference of two squares. It is two terms with a minus in between, and everything in the problem, variables, numbers, are all perfect squares. So splitting it up, you know it's going to split up where one parenthesis has a plus sign and one has a minus sign. The way you split up x squared will be x times x. Now I know 16 breaks up into other ways other than 4 times 4, but I don't want to use 8 and 2 because I want my parentheses to look the same other than that middle sign. So I'm going to break up 16y squared into 4y and 4y. And so then this is your final answer. Make that a little bit smaller. Okay, so that's a difference of two squares. Let's check out these other two examples. Now going back in our notes from before, we talked about something else that was called a perfect square trinomial. A perfect square trinomial is a trinomial that you get when you multiply a binomial times itself. It makes sense that it's called a perfect square trinomial because when you multiply a number times itself, you call it a perfect square number. So if you multiply a binomial times itself, its product is called a perfect square trinomial. It's not called a perfect square number because it's not a number. So looking here, both of these, here and here, are what we call perfect square trinomials. Perfect square trinomials is what you get whenever you multiply a binomial times itself. Okay? So the way that we can recognize a perfect square trinomial is it will be three terms, and specifically the first and last terms are perfect square values. Okay? So when you go to do a problem like this, so let's look at an example. Okay? Example 1. Let's look at x squared plus 8x plus 16. So something in this form, okay, again, since it is a binomial in the form of ax squared plus bx plus c, it will factor into two binomials. So it factors into two binomials, except this time the two binomials will be identical. Okay, so that's something that's nice to be able to recognize a perfect square trinomial because you know the two binomials have to be exactly the same, which makes the guess and check process really easy to do on these problems. So I recognize the first and last terms to be perfect squares in this trinomial. So I know that x times x is going to give me x squared. These are all plus signs, so these have to be plus signs. Again, I know that there are other ways to multiply to 16 other than 4 times 4, but since I want the parentheses to be the same, it has to be a 4 and a 4. And you can check your middle term in your head or on paper. You can see here you're going to get 4x. Here you're going to get 4x, which is 8x. Okay? Now, the perfect square trinomial, you can definitely leave your answer like this, but you will often see the answer written as the binomial to the second power. So on our answer keys from now on, this is how you will see your answer. If you left your answer in this broken out form, I would completely accept it, but just know on many multiple choice tests, they like to leave the answer like this. So you just need to be able to identify that these are the same things, okay? So let's look at another example here. Example 2. Let's do 4x squared plus 12x plus 9. This is a perfect square trinomial. It's 3 terms where the first term and the last term are perfect squares. The reason 4x squared is a perfect square is because both 4 and x squared are perfect squares. You know it's going to factor into 2 binomials, and they have to be the same. So the only way to split up 4x squared would be 2x and 2x. And the only way to split up 9 would be 3 and 3. Recognizing the pattern that they're all plus signs, this has to be plus signs as well. I can then rewrite my answer as 2x plus 3 to the second power, and there's your final answer. Last example is for you to try. X squared minus 2x plus 1. Take a moment, pause the video, and try this problem on your own. In doing this problem, recognizing it as perfect squares, both x squared and 1 are perfect squares, so you know it's going to factor into 2 binomials that are identical. Remember that a perfect square trinomial could be all plus signs, or it could be a minus and then a plus sign. And that's because if the last term is positive, we know that 2 negatives when multiplied give me a plus, but when they're added, they give me a minus. So knowing that the binomials have to be the same, hopefully you did x and 1 and 1. In order to get a positive product, but a negative sum, you would have to use 2 minus signs. Checking your middle term, that would give you negative 1x, that would give you negative 1x, which is negative 2x. And then since the binomials are the same, I can write them as x minus 1 to the second power, and then there is your answer. You can definitely use the grouping method on any of these problems, but I think if you can recognize the pattern, guess and check, or if you can recognize the pattern, guess and check is a really great way to get through these problems in a more efficient way. So if you like this video, hit like, subscribe to the channel, and best of luck with your practice.